Hey everyone, welcome back. Today we are going to solve problem number 1269, number of ways to stay in the same place after some steps. First, we will see the explanation of the problem statement, then the logic on the code. Now let's dive into the solution. So in this problem, we have a pointer starting at index 0, right? So here we have a pointer. And this array length is represented by the given input array len, right? Then we have to move, then we can move left or right within the array from the current position 0, but after moving left or right we have to return back to the 0th position. So we need to calculate in how many ways we can move and come back to the 0th position, right? So here we have given steps input, so we have to move 3 steps, then we need to return back to the 0th index, right? So we need to calculate total number of ways we can reach 0th index after the completion of 3 steps, right? So now we will see how we are going to do this. So initially we need to do integer division by 2 on the steps, and we need to add 1 to it. So here this represents maximum number of position you can consider while staying within the problem's constraints. It's used to determine the size of the dynamic programming array to efficiently solve the problem, right? That is the reason we are performing this calculation. Then we need to take the array length, that is 2, and we need to take minimum between these two. So here this will be 2 and this will be 2 as well. Minimum between these two will be 2. So we can keep this to a variable called n, right? So n is equal to 2. So here we have constructed the dynamic programming array. So here the length of 2 represented by the n we calculated, right? That is the reason this array's length is 2, right? Similarly, we are going to construct n arrays based on the number of steps plus 1, right? So the number of steps plus 1 will be 4. So here we have 4 such arrays. So at the index 0 and 0, that is this value, we are going to start this one with 1. So we are going to have 2 loops where we are going to start from the first array in the jth column. So jth column will start with 0, right? So in the second loop, before we proceed, we have to go back to the previous array and we need to take the value in the similar position. So here 1 is in the previous row, right? The previous row we have 1 at the same index where we are currently now. So we need to copy that 1 here. So now we need to check whether we can move left and right? So here we can check that by using the j index. If j is greater than 0, we can move left. If j is less than n minus 1, so here n is 2, so n minus 1 will be 1. If j is less than 1, we can move right. So here we have j is equal to 0. So we are here. So we can't go left side, right? We can't go left side, but we can go on the right side, right? So we go back to the previous row and we need to go to the right position. So the right position is j plus 1, right? So here j plus 1 is 0. So the j is at these indices. I is in these indices, right? So here we have 0. So we need to add this 0 in the current right position in our current row. So in the current row we are here, but we have moved rightwards, right? So here we have 0. We need to add 0 to the current position. So here 1 remains the same. So we move back. So now j becomes 1. So now we are in the first row and the jth column. We need to take the value in the previous row at the same position. So here we have 0. We just have to copy 0 here. 0 remains the same. So then we need to check whether we can move left or right. So here j is greater than 0. So we can move left. So we go back to the previous position, and what is the left value? That is j minus 1. So here j is 1, minus 1 is going to be 0. So we go to the previous row and the jth index, jth column, that is 1. We have 1 here. So we take that 1 and add it here in the current position. So here we are going to get 1. So now we are done with the columns. So we move back to the next row, that is 2. So I becomes 2 and j will start from 0 again. So now we go back to the previous row in the jth column. So in the jth column we have 1. So we take that 1 and copy in the current position, right? So now we need to check whether we can move left or right. So here we can't move left since it will be out of bound, but we can move right. So here currently we are here, right? So we can move right. So we go back to the previous row and the j plus 1 position. So we are trying to move in the right direction, right? So we need to take the j plus 1 index value. So j is 0, j plus 1 will be 1. In the previous row, j plus 1 is this index. So we are going to take this value and add it to the current position. So here is going to be 2. So now j becomes 1. So currently we are here. So we have to go back to the previous row and we need to copy the previous jth value, that is 1. Then we need to check whether we can move left or right. So here we can't move right, but we can move left from this position. So we go back to the previous row and j minus 1 position. So that will be 0. So this value, we will be adding this to the current position. So here it becomes 2. So now I becomes 3 and j will be 0. So now we are in this position. So before proceeding in the second row, we go back to the previous row. We take the current position's value and copy. So here we will be having 2. So then we need to check whether we can move left or right. So from this position we can't move left, but we can move right. So we go back to the previous row. In the j plus 1 index, there is 2. We add that 2 to the current position. So here it becomes 4. So then we are going to be in this position, that is j will be 1 now. So we have to go back to the previous row and we need to copy this value here, right? So here it becomes 2. So then we need to check whether we can move left or right. So here we can't move right, but we can move left. So we go back to the previous row and we go back to the j minus 1 index, that is 0. So we take this value and add it here. So it's going to be 4. So here this 0th index represents the stay position, right? This is the stay position. So using steps as my index, so we can use this steps to arrive in the third row, and we have to take the 0th index value, that is the stay positions value. That will be the total number of ways, right? So here it is 4. That's how the logic is. Now we will see the code. Before we code, if you guys haven't subscribed to my channel, please like and subscribe. This will motivate me to upload more videos in future. Also check out my previous videos and keep supporting guys. So initially we need to calculate the minimum between the calculated value and the array length. So this will be our n, right? Then we need to construct the dynamic programming array using these steps and the n value, right? Then we are initializing the first value as 1, that is the 0th row and 0th column as 1. So now we are going to use 2 loops where we will be starting the ith index will be based on the steps, So we are going to start from the first row. Then the second loop will be the jth index, that is the column, will be based on the n that we calculated, right? So for each iteration in the second loop, we have to initialize the previous value for the current position. Then we need to decide whether we need to move left or right, and we perform the calculations. Then finally we can use the steps to identify the row, and in the 0th position, that is the stay position, the total number of ways that we can reach the 0th index will be calculated. So then we need to divide it by mod, that is just to avoid the larger values in the answers, right? That's all the code is. Now we will run the code. As you guys see, it's pretty much efficient. Thank you guys for watching this video. Please like, share and subscribe. This will motivate me to upload more videos in future. Now to check out my previous videos. Keep supporting. Happy learning. Cheers guys.